Three gases, X, Y, and Z, were mixed in a closed container and allowed to reach equilibrium. A change was imposed at time t, and equilibrium was reestablished. The concentration of each gas is plotted against time. Which of the values below is closest to the equilibrium constant value for the reaction if X is your reactant? So the question is asking you which value is closest to the equilibrium constant. You know that the equilibrium constant takes in concentration, and the concentrations are arranged in terms of the equilibrium expression. And then the equilibrium expression you get from an equation for a reversible reaction. So this is me annotating the question and sort of brainstorming to see what piece of information I need to get together. So the next step in this question is realizing, hey, I've done my brainstorm. Equilibrium constant means I'm subbing in concentrations, I'm subbing it into the equilibrium expression, and the equilibrium expression I get from the equation for a reversible reaction. In this case, you don't get given the equation. There are two things that you look at for the equation. You need to see whether they're on the left-hand side of the arrow or whether or not they're on the right-hand side of the arrow. And then the other thing you had to look at was your stoichiometric coefficient. When you look at a concentration versus time graph, you don't look at the immediate change. When you're trying to figure out an equation, you look at this gradual change. When they're on the same side of the arrow, the change has to be the same. The change has to be the same. So when you're looking at this graph, you're looking at the gradual changes. So you're looking at these ones here when you're trying to figure out an equation. That one goes down, that one goes up, and that one goes up. So which substances are on the same side of the arrow? Y and Z have to be on the same side, and then X is on the other side. And then you have to figure out which side it's on. They've already told you in the question that X is the reactant. So you know X is on this side, then you have your arrow, and then you have Y plus Z on the other side. So one of the things you figure out is whether or not it's on the left and the right-hand side. And then the second thing you need to complete your equation is what are these coefficients out the front, and you get that from the ratio of the changes. When you're looking at the ratio of the changes, you look at it from when the initial change ends and then the new equilibrium. So you don't look at the start up here. You look at it when the initial change is done. So this is the gap for X, and this is the gap for Y, because that's the change there. And then this is the gap for Z. What's the ratio of X to Y to Z? It's 1 to 1 to 1. So this is your final equation. And then your only job now is to sub in your values to get your equilibrium constant. So K is the concentration of Y, concentration of Z, over concentration of X, and then you read your values from here. So your equilibrium values, whatever that one is, for Z, for Y, and for X, sub it into this expression here, and you'll look for the value that's closest to the value that you get.